In part 4 of this lecture, we're going to take a look at the difference between descriptive and inferential statistics. The statistics that IO psychologists use in their work can be divided into these two groups. Descriptive statistics describe the data. Inferential statistics allow us to draw inferences, conclusions about the data. In most situations, an IO psychologist would use both types of statistics to better understand the phenomenon they're interested in. More specifically, descriptive statistics can be used to summarize, organize, and describe a data set. For example, the data can be organized into a visual. Frequency distribution tables and histograms are some of the most common ways that data can be visually represented. Whatever the topic of interest, the scores are along the horizontal axis, and the frequency of that score, how often, how many people score at that level, is represented along the vertical axis. We can look at least 3 different characteristics of a frequency distribution in order to better understand it. Measures of central tendency, variability, and skewness. The mean, median, and mode of a distribution are called its measures of central tendency, because these statistics help us identify the center of the distribution, where most people fall or score. The mean is the average score. The mode is the most frequently occurring score, the score you see the most of. And the median is the score that separates, that splits the distribution into 2 equal halves. The second characteristic is variability. High levels of variability means we have a lot of different scores. We have highs, lows, and some in the middle. This is what we want. We want variability. If everyone scores the same and variability is low, it's going to be very difficult for us to figure out why small differences exist. Related to variability, we have range and standard deviation. Range is simply the difference between the highest score and the lowest score. An even better measure of variability is standard deviation, the average amount of distance between each score and the mean. We basically have to find the difference between every single person's score and the average, and then average all those differences together. And then we have skewness. This tells us whether the majority of scores fall to the left of the mean, below the mean, or to the right of the mean, above the mean. While the median is unaffected by skewness, the mean of a distribution will change in the direction of the skew. In a perfectly normal distribution, those 3 measures of central tendency are the same value. But that rarely happens because very few distributions are perfectly normal. We look at skewness to understand what's going on. We usually begin with descriptive statistics and then move on to inferential statistics because they're a little bit more complicated. These statistics are used to test our hypotheses about the topics we're studying. Think t-tests, f-tests, chi-square tests. Based on these statistics, we make decisions about how to treat the data, about the significance of our data, and to draw conclusions about the phenomenon we studied. The most basic question that we're trying to answer is, are 2 or more groups different beyond what we would expect by chance? Are the differences due to something we're studying or some other variable, or are the differences natural, expected, normal? One of the questions that students often ask me is, how do I know how many people I need to survey or include in my experiment? It has to do with statistical power. This is the probability of finding a statistically significant difference when there is, in fact, a real difference there. This statistic is something that we calculate before we ever collect data in order to determine how many people we need to include in our study. The more people you include, the more confident you can be in your data and in your inferences, in your conclusions. After we collect data, we use another inferential statistic to determine whether our results indicate a true difference or whether that difference could have happened by chance. When the statistic, the p-value, is less than the alpha value, and normally we choose 0.05 for the alpha, we can say that the results are statistically significant. It is big enough that it is not due to chance. There is something else going on. Hopefully, we have the data in order to figure out what that something is. If the p-value is greater than 0.05, that tells us that in any given situation on any given day, we might get the same exact data. It doesn't have anything to do with our intervention, our topic. This is just your normal differences you would find between any two groups. This statistic doesn't tell us about the strength of the relationship, and it doesn't tell us how important our results are going to be within the community. This statistic tells us whether the differences are big enough to warrant further investigation.